myself Timid Choksi. I am assistant professor in LJ. Student, welcome to session number 1 of trigonometric leveling. So in this chapter, means in this first session, I have explained about some introduction part of trigonometric leveling, means what is a trigonometric leveling, different terms used in a leveling I have explained in a detail, and I have explained about the different types of the trigonometric leveling as well as a different type of cases. Given an overview of these cases, I have explained in this particular session. So in a session number 1 of trigonometric leveling, first I have explained what is a leveling and what is a trigonometric leveling. So student, you know that you have studied already in a particularly basic civil engineering subject some concept about the leveling. So leveling is a method of determining the relative heights, elevation of various points. So we have find the elevation of various points. So is called as a, or this method is called as a leveling. There are two types of leveling are there. First is a direct leveling and second is an indirect leveling method. So in a direct leveling, the difference in elevation of the point is determining using a leveling instrument like dumpy level, leveling star. Student, you have already studied in a basic civil engineering subject direct leveling. Here I give one example. Now you have find the elevation or height of point A and B using the dumpy level. So you directly find the leveling or difference between them between point A to B. So this type of leveling is called as a direct leveling. So you have find that directly difference between A to B distance means height. So is called as a direct leveling. But here in a particular subject in a survey and particular this chapter, you have studied about the indirect method, not a direct method, because direct method you have already studied in a previous subject like basic civil engineering subject. Why you have studied an indirect method? Because some field are different, some terrain are different, some uneven field are there. So you have not taken direct leveling, you have going method of indirect method. So I have explained in a detail what is a trigonometric leveling. So clearly you have please student attention are there. Trigonometric leveling is an indirect method of leveling in which the relative heights means elevation of various point means object are determined from the vertical angle, are measured with transit theodolite, and the horizontal distance are measured directly with the tap. So these are a definition. Now I have given means describe that with figure. You know that this is our LJ campus ground and this is our building. Now you have find the height of the building means this point you have measured. So this method you have not directly find the elevation. So you have taken a method is an indirect method. Now this is our instrument means theodolite are used, transit theodolite are used for finding the vertical angle, and the horizontal distance you have measured with the depth. So our main goal is you have find relative heights of this point means find the elevation of this object with using vertical angle, but vertical angle you have find measured with the transit theodolite, and you have find the horizontal distance measured with the directly with the depth. So I have repeat this definition. Trigonometric leveling is an indirect method of leveling in which the relative heights means you have find the particularly this height of various object means point you have find particularly this object. So you have find the vertical angle are measured with transit theodolite means you have used the particular some instrument is called as a transit theodolite, and the horizontal distance are measured with the tan. So this is our definition of trigonometric level. You have studied direct leveling in a basic civil engineering. You know that. I have given an example. You have find the difference between this point A and B. So you're directly using the dumpy level. First you have find the elevation of A, then you have find the elevation of B and subtract them. So you have directly find the difference between them. But some field are different, some object are different, some terrain is a difficult, so you have used the indirect method. So it is called the trigonometric level. Now you have uh, understand this concept. Now these are a use of particularly trigonometric leveling. Trigonometric leveling is a commonly used in a topographical work to find out the elevation of the top of the building, chimney, church, and so on. So when you have find the height of the building, church, and extra and chimney, so you use the trigonometric level. Also, it can be used to advantages in a difficult terrain such as a mountain area. So when you have not used the direct leveling, so you have used the indirect method, means trigonometric leveling, and generally trigonometric leveling are used in a difficult terrain area like a mountain area. So now next third topic is, first topic is a definition, then use. Now third concept is uh, trigonometric leveling types. So depending upon the horizontal distance between station, so trigonometric leveling can be subdivided into two types. So depending upon the horizontal distance between the station, there are two types. One is a plane trigonometric leveling and second is a geodetic trigonometric leveling. You know that a primary division of surveying is a two, divided into two parts. One is a plane and one is a geodetic. Similar that, depending upon the horizontal distance between the station, there are two types. One is a plane trigonometric leveling and second is a geodetic trigonometric leveling. Here, plane trigonometric leveling I have described in a detail. It is the assume that the distance between the point observed are not large, so that either the effect of curvature and diffraction may be neglected. You know that in a plane surveying, I have already explained in a introduction part session, there are two primary division. One is a plane and geodetic, second is a geodetic. In a plane surveying, you have considered that the area is larger than 250 kilometers square and curvature and diffraction are neglected. So here, when you assume that, here I some given some example, you have assumed that the difference between, means distance between station to this object are not large, so it is called as a plane trigonometric level. Means up to distance 18.5 kilometer you have considered as a plane trigonometric level. But when the distance between the instrument station to object is very large, so assume that this is called as a geodetic trigonometric level. So here, particular geodetic trigonometric leveling, you have considered the effect of curvature as well as the refraction. Why? Because the distance are larger. So you know that when the distance between the station to object is large, so effect of curvature and refraction develop, because some instrument means some obstruction are there, some refraction are there. So particular in this field, you have considered the curvature and refraction may be considered. So this type of trigonometric leveling is called as a geodetic trigonometric leveling. So depending upon the, listen student, depending upon the horizontal distance between the station to object, you have considered the two types. One is a plane and one is a geodetic. Student, particular whole the chapter means trigonometric leveling are, you have considered only plane trigonometric leveling, not a single example of geodetic trigonometric leveling. You have considered that, assume that the distance between station to object is a very small, so you have considered as a plane trigonometric leveling. So I have repeat this particular step, particular line. You have considered whole the chapter in a plane trigonometric leveling. So all the distance are given in a particularly small. So you consider as a plane trigonometric level. So this is a classification. Now, some technical terms used in leveling. You have already studied in a basic civil engineering while you have studied the leveling part, but I have repeat this term with figure so you clearly understand. So first definition is a datum. So datum plane is a line with reference to which level of other line of surface are calculated. So you have considered one reference line and you have find all the points of elevation with reference to the some datum point. So it's called as a datum. Like in an example, here you have find the particularly this height means height of instrument. So this is a datum point. You have considered that benchmark is 410 meter and this height is 6.31. So you have considered that 416.3 feet you have the elevation from the datum point. So you have considered the datum means datum plan is line with reference to which level of other line or surface of the line are calculated. So datum is the one type of reference line. Now reduce level RL. Height or depth of a point above or below the assumed datum is called as a reduced level. So the point are below or above the datum. Assume that this is called as the RL, means reduced level. Here I have given an example so you clearly understand. The absolute datum level of point A is 100.522 meter, means here A point and datum is given and this is a point A is above the particular datum line and its datum line is 100.522 meter and the change the level is 2.312 meter and the B level is 2 point you have find the particularly using the dumpy level and find the height of A and B is 2.312 and respectively 2.533. So when you have find the RL of B, so you know that here this is a 100.552 is a datum point. The difference between the A2 and B point is 0.221. So your reduced level at point B is 100.522 minus 0.221. So it's 100.301 meter. It is the RL of the B. So you will find the directly reduced level. But in a particular syllabus, you have used the indirect method. So, in an example, already you have given directly uh, reduced level is given. So, this is the definition of reduced level. Now, benchmark. You are already studying in the basic civil engineering subject. Benchmark is a fixed reference point known as elevation. Always in an example, means given in an example, benchmark value is given fixed. So this is a fixed reference point of known elevation. Now mean sea level. This definition you have considered on. Remember that MSL means mean sea level is obtained by making hourly observation of the tides at any place over a period of 19 years. MSL adopted by the Survey of India is now Bombay, which was Karachi earlier. So MSL in particular syllabus you have considered that in a particular chapter MSL is similar that you have considered the datum point. So I have here clearly seen in a photograph MSL in a bracket datum. So MSL you have obtained by making hourly observation of tides. Tides you know that at any place over a period of 19 years and then you have finalized the MSL. MSL approved by the Survey India, now Bombay, which was Karachi earlier. You know that uh, you have visit the Kalupur railway station and any type of particular major station of the Ahmedabad and in India, the in a yellow color written in a yellow color MSL and some value are given. So MSL are fixed by Survey Agency India, in Survey of India. So you have directly taken from the value. And last, height of instrument, HI. The elevation of the line of sight with respect to assumed datum is known as the height of instrument. Here you clearly seen this is the height of instrument. So this is a terms used in a leveling. I will repeat this term: datum, RL, BM, MSL, and HI. So this is the term used in a leveling. Now, understanding the concept of trigonometric leveling as well as the types of trigonometric leveling, term used in a leveling. Now, it is the most important. The different type of cases are there. So, particular in this session, student, or explain only overview of the cases. So you clearly understand what is the cases of or what is a trigonometric leveling and what is your find in particular chapter. So depending upon the field condition, the measurement then can be made with the instrument available. The following three cases are involved. So depending upon the, you know that in a particular survey line, the different field condition are there. Some in uneven ground, some flat ground. So different field condition are there, and the different type of instrument are there, and different type of measurement you have taken. So depending upon three factor, one is a field condition, measurement, and instrument available. Following three cases are involved. First case, base of the object is accessible. You have remember that base of the object is accessible. Case number 2, base of the object is inaccessible, but instrument station and elevated object are in same vertical plane. And third case, base of the object is inaccessible, but instrument station and elevated object are in not same vertical plane. Here these are difference. First case accessible. First I have explained with figure, so you clearly understand what is accessible, what is inaccessible. Accessible means you have reached this particular point, you have find particular object, so reach can be easily. But when you have not reached the easily from particular you have find the object, so this point is called as an inaccessible. You have already studied in a intersection method of plane table survey, but I have given with example with figure, so you clearly understand. First case is a base of the object is accessible. Here you know that this is our LJ campus ground. This is our instrument. You have find the particularly height of this object. So here you have clearly seen in a figure the base of the object means this is the object and our base are this particular foundation. You have clearly understand. These are our 1 minute. I have seen particular marker. So this is a building means you have find this object and this is our base of the object. So you have clearly or find the distance between instrument station to base of the object. So this type of condition is called as the base of the object is accessible. Means you have reached particularly this particular point, you have find the elevation of this point means these are our object, but its bases are there. Here you know that the bottom point of the building, you have find the top of the building, but the bottom of the building is our base. So you have clearly find the distance between instrument station to base of the object, and can you have means you have reached easily to particular base of the object. So this type of condition is called as the base of the object is accessible. Here you know that here you have considered that this is our instrument P. This is a LJ building. You have top of the point. You have find the particular elevation of this object R. Our base is a particularly this Q point. So you have easily find with using the chain or tap. You have easily find the distance between instrument to object. So this is called as this case is called as the base of the object is accessible. So case are you know that case are based on the particularly different type of field. So this is our first case. Only I have given an overview. I have derivation. I have explained a derivation and example in a second session. Now in the first session only I have given an overview to show you have clearly understand. Now second case, base of the object is inaccessible. Instrument station and elevated object are in same vertical plane. So here you have find a particular elevation of this object. Here you know that this is a LJ campus are there. Here you have find the particularly this object, but here base is not base is not accessible. So this type of condition you have to say that the base of the object is not accessible, means inaccessible. You have not reached the base of and find the accurately directly with tape or chain. So this type of condition is called as the base of the object is inaccessible. But here next line is says as a instrument station and elevated object are in same vertical plane. Means these are our object, means elevated object, and the instrument. Student, in a case number 2 and 3, when the base of the object is inaccessible and you have find the particularly height of the object, you have used the two instrument, not a single instrument. With using the two instrument means you have set up the instrument at two station and you have easily find the object, means reduce level of this particularly object. So here clearly seen the elevated object and the instrument station are in a same vertical plane. So this is case number 2. Base of the object is inaccessible. Why inaccessible? Well, because you have not reached the base of the particularly object, because there are no base are given. So this type of field condition you have considered as a base of the object is inaccessible. And next, instrument station and elevated object are in same vertical plane. Here clearly seen this is a particularly object word plane and this is the instrument plane. These are in a same vertical plane. And student, third case, base of the object in inaccessible. In particular case you have find the particular station object inaccessible, but instrument station and elevated object are in not same vertical plane. You know that when the object is inaccessible to use the two instrument, but here uh, you have not the instrument set up in a same vertical plane. So you have means some field are there, some obstruction are there, and you have not set up the instrument in a same vertical plane. So you have set up the instrument in a different level. So this type of condition you have called as a case number 3. Base of the object is inaccessible and instrument station and elevated object are in not same vertical plane. Here in a same vertical plane there are two instruments are used, P and Q. Base of the object is not accessible, so you do not you cannot directly find the capital D. You have find the capital D means horizontal distance between two instrument to object is you have find the some modify formula. Here in a case number 1 you have directly find the distance between instrument to object with tap or chain, but here base of the object is inaccessible, so you cannot directly find the capital D using the tap or chain. You have find the some modify formula, so you have find the value of capital D. But here the object and instrument X is in the same vertical plane. But here in case number 3, there are two instruments P and Q. But here P and Q vertical plane is a different. So this is a case number 3. And so student, thank you so much watching this video. In this video I have covered uh, definition of trigonometric leveling. I have explained the use of trigonometric leveling. I have explained about the different types of trigonometric leveling, terms used in particular trigonometric leveling, and I have explained about the different only overview of the cases of trigonometric leveling. So thank you so much for watching this video.